The next method is based on measuring the electrical conductivity of the media. The principle is quite simple. The media in the different heat exchanger circuits usually have different conductivity levels. If there's a leak between the circuits, the media start to mix, which causes a change in conductivity. Special sensors detect these changes, indicating possible damage to the plates or seals. One of the main advantages of this method is that it's simple to implement. All you need is a conductivity sensor and a control fluid. Another advantage is safety, since no toxic or hazardous substances are used. The test can also be carried out while the system is operating, provided that the media in the two heat exchanger circuits have different conductivity levels to begin with. As for the disadvantages, this method isn't suitable for every system. As we mentioned earlier, if the media in both circuits have the same electrical conductivity, the method simply won't work. It also can't detect gas leaks, as it only works with liquid media. Another limitation is that it doesn't show the exact location of the damage. It can confirm that there's a leak between the circuits, but it can't pinpoint where the leak is or detect an external leak. This method can actually be used while the heat exchanger is in operation. In fact, it's one of the methods that can be applied without shutting down the system.
As I understand it, this method can essentially be classified as a hydraulic method. We have two sections of the heat exchanger containing liquids with different conductivity levels, and we monitor changes in conductivity in one section caused by liquid flowing in from the other. As I understand it, the liquid with the higher conductivity comes from the pressurized section. Igor, am I interpreting the principle correctly? How would you explain the principle behind this method of checking heat exchangers for potential leaks?
Yes, exactly. With this method, liquids are used in both circuits. In this case, for example, anhydrous sodium sulfate is used as the electrolyte. The device then measures the change in conductivity caused by the leakage of this salt solution from one circuit into the other.
Right. But if we say that the hydraulic method isn't accurate enough, how much more accurate is this method? Or more generally, what makes it better?
Well, the principle behind this method is different. In a hydrostatic test, we measure changes in pressure, whereas here we measure changes in conductivity. So, even purely theoretically,
It will be more accurate?
yes.
Okay, thank you.